Hello, 9th graders. I am still your virtual teacher for this week. I am Mr. Eliezer Mamugay from Labit National High School. Today, we will learn how to solve quadratic equation. There are various methods that possibly be used in solving quadratic equations, and one of which is extracting square roots. So at the end of this video lesson, we are expected to be able to solve quadratic equations using extracting square roots. When we say solving quadratic equation, we are going to solve the value of the variable in the given equation. Karamihan sa mga estudyante ay kilala ito sa tawag na finding the value of x. At alam kong familiar rin kayo rito because you've been doing this since you were in grade 7. Remember your lesson on solving linear equation in one variable? We will just apply the same concept in this new lesson. The only difference is the method of solving the equation since it is quadratic. Pero don't worry, madali lang naman ito. So let's begin. First, keep in mind that this method, extracting square root, cannot be utilized in solving all types of quadratic equations. Ibig sabihin, may mga pagkakataon lamang na pwede natin itong magamit. And it is when the quadratic equation is transformable into the form of x squared equal to k or ax plus b, the quantity squared, equal to k, where k represents the constant. Now, here are the steps in solving quadratic equation by extracting square roots. Step 1. Transform the equation so that a perfect square is on one side and a constant is on the other side of the equation. The equation will look like this one or this one. Step 2. Use the square root property to find the square root of each side. And step 3. Solve each resulting equation. Also, take note of these three following properties as we apply this method later on in solving quadratic equations. 1. If the value of the constant k in the equation is greater than 0, the equation has two real solutions and it will yield positive and negative values. 2. If the value of the constant k in the equation is 0, the equation has one real solution and that solution is 0. 3. If the value of the constant k in the equation is less than 0 or negative, then the equation has no real solutions. Now, to help you understand this better, let's do your activity number 1, 2, and 3 using different examples. In your activity 1, you're going to solve the following quadratic equations by extracting square root. It is entitled the simplest. It is called the simplest because, as you can see, all the equations in your activity 1 are already in the form of x squared equal to k. All you need to do is to apply the square root method and solve. Let us try some examples. Example 1. X squared equal to 9. In this equation, the value of the constant k is 9. And based on the property, if the value of the constant k in the equation is greater than 0, the equation has two real solutions. So we are expecting two values of x in this quadratic equation. Now, applying the square root method, this will become square root of x squared equal to positive and negative square root of 9. If we take the square root of x squared, the exponent will be terminated. So only the variable x will be left on the left side. On the other side, the square roots of 9 are positive and negative 3. Therefore, the value of x in this equation is positive 3 or negative 3. Example 2. Y squared is equal to 16. The value of constant k in this equation is 16, which is still greater than 0. So again, there are two values of y waiting for us. So let's take the square root of y squared and 16. The answer is y equal to positive negative 4. Or we can say y is equal to positive 4 or y is equal to negative 4. Example 3. Z squared is equal to 0. The constant k in this equation is 0. And according to the property, if k is 0, then the equation has one real solution and that is the 0 itself. What does it mean? Even if we take the square root of 0, the answer is still 0. So in this equation, z is equal to 0. Example 4. X squared is equal to negative 25. In this equation, constant k is negative 25. That is less than 0. And if k is less than 0, based on the property, there will be no real solutions in the given equation. Because if we take the square root of negative 25, it is undefined. Take note that there is no negative number with a perfect square. Hence, there is no square root for negative values. So the answer in this equation is x equal to undefined. For your activity 2, you're still going to solve the following quadratic equations by extracting square root. This activity is entitled Constant Beside Me. As you can see, there is a constant number and a numerical coefficient besides the perfect square. What we need to do this time is to transform first the equation into the form x squared equal to k. Example 1. Solve the quadratic equation x squared plus 3 equal to 7. Step 1. Transform the equation into x squared equal to k by applying some properties of equality. Remember, we need to isolate the unit that is perfect square on one side of the equation. Ibig sabihin, kailangan nating tanggalin si 3 dito sa side na ito ng equation upang nag-iisa na lang maiiwan si x squared. And to do that, we need to apply the addition property of equality. Let's add negative 3 to both sides of the equation to remove 3. So 3 will be terminated and then add like terms. And it will become x squared equal to 4. Ayan, tapos na tayo sa step 1. Step 2, square root both sides of the equation. The square root of x squared is x, and the square root of 4 is positive negative 2. So the answer is x equal to positive negative 2. Example 2. 3m squared equal to 27. To transform this equation into x squared equal to k, we simply need to remove the coefficient of the variable m. And to make it happen, we will perform division property of equality. We will divide the two sides of the equation by 3. So 3 will be cancelled out. On the other side, 27 divided by 3 is equal to 9. So this will become m squared equal to 9. Step 2, square root both sides of the equation. And then solve. Square root of m squared is m. And square root of 9 is positive negative 3. So the answer is m equal to positive negative 3. Example 3. 4x squared minus 144 equal to 0. As you can see, aside from there is a numerical coefficient on the variable x, there is also a constant number beside it. Now, all we need to do is to remove them one by one. But take note, remove first the constant number before the coefficient. So add positive 144 on the two sides of the equation to remove negative 144. This will become 4x squared equal to 144. And then, remove the coefficient 4 by dividing the equation by 4. Our new equation now will be x squared equal to 36. Then proceed to step 2. Square root both sides of the equation. And then, solve. The square root of x squared is x, and the square root of 36 is positive negative 6. So the answer is x is equal to positive negative 6. Let's try it one more time. The equation is 2b squared plus 5 equal to 37. Remember, remove the constant before the coefficient. So let's add negative 5 on both sides of the equation to remove the constant 5. The resulting equation will be 2b squared equal to 32. Afterward, divide the equation by 2 to remove the coefficient of the variable b. The new equation now will become 2b squared equal to 16. And then, we take the square roots of b squared and 16. Our final answer is b equal to positive negative 4. For your activity 3, we have the activity title squared binomial, and you are still going to use the method extracting square root to solve the given quadratic equations. Example 1. Solve the quadratic equation x minus 2, the quantity squared, equal to 9. Again, let's do it step by step. Step 1. Transform the equation into x squared equal to k, or ax minus b, the quantity squared, equal to k. Now, since the given equation is already in the form of ax plus b, the quantity squared, equal to k, we can proceed to step 2. And step 2 is to square root both sides of the equation. The square of the exponent of the quantity on the left side will be terminated, and on the other side, the square root of 9 is positive negative 3. So this will become x minus 2 equal to positive negative 3. Now to solve the value of the variable x, we need to remove the constant besides it. So we're going to add 2 on both sides to eliminate the negative 2. Then we will come up with two different equations. The first equation is x equal to positive 3 plus 2. Then the other one is x equal to negative 3 plus 2. Then solve each resulting equation as our last step. For the first equation, x is equal to 5. While on the other equation, x is equal to negative 1. Example 2. X plus 10, the quantity squared, minus 5 equal to 31. The first thing to do is to transform this equation into ax plus b, the quantity squared, equal to k. What we need to do is to remove the negative 5 on the left side of the equation by adding 5 on both sides. After that, the equation will become x plus 10, the quantity squared, equal to 36. Then proceed to step 2. Take the square roots of the two sides of the given equation. After doing so, it will become x plus 10 equal to positive negative 6. Then add negative 10 to remove the constant on the left side of the equation to solve for x. And again, it will result into two different equations. The first equation is x is equal to 6 minus 10, and the second one is x is equal to negative 6 minus 10. By solving these two equations, we will get negative 4 and negative 16 as the value of x respectively. For our example 3, the given equation is 4 multiplied by x plus 3, the quantity squared, equal to 32. Divide this equation by 4 to remove the constant 4 from the left side of the equation to make it in the form of ax plus b, the quantity squared, equal to k. So the equation will become x plus 3, the quantity squared, equal to 8. Then proceed to step 2. Square root both sides of the equation. This will be equivalent to x plus 3 equal to positive negative 8. Then add negative 3 on both sides to remove the constant 3 beside the variable x. Again, this will also give us two different equations. X equal to the square root of 8 minus 3 and x equal to the negative square root of 8 minus 3. Since 8 is not a perfect square, this can be our final answer to the problem. Let's try another example. Solve the equation 3 multiplied by x plus 2, the quantity squared, minus 11 equal to 25. If you find it difficult to answer, just follow the steps we did in the previous examples. Our first objective is to transform this equation into ax plus b, the quantity squared, equal to k. So just be patient and do it step by step. First, remove the negative 11 by adding 11 on both sides of the equation. This will result into 3 multiplied by x plus 2, the quantity squared, equal to 36. Next to remove is the multiplier of the quantity x plus 2 squared. And to remove, divide the equation by 3. This will become x plus 2, the quantity squared, equal to 12. And that's it. We're done with the step 1. The second step is to take the square root of the two sides of the equation. The new equation now is x plus 2 equal to positive negative square root of 12. And then remove the constant 2 by adding negative 2 on both sides of the equation. This will also result into two different equations. X is equal to the square root of 12 minus 2, and x is equal to the negative square root of 12 minus 2. And again, since 12 is not a perfect square, this will be our final solution to the problem. And here ends my discussion for this lesson. If there is something you don't quite understand, try to watch the video again, or ask your teacher about it. Thank you and see you on our next virtual instruction.